Here we are. This is John Park, and you've just tuned into John Park's Workshop special early time of the day edition. Early for me, at least. I'm still drinking coffee. It is 11 o'clock-ish here in Pacific Coast time in California. It's still weirdly cold out and gray. I'm wearing a jacket in the workshop. Thank you, Mr. Certainly, over in the Discord chat for letting me know we've got good, loud, and clear audio. I haven't had any false alarms on my little audio alert thingy here. Adam Bachman has been working on the code for it. I haven't talked to him in a while, so I don't know if it's actually working or not. But I'll try to keep a good, clear, clean line of sight on the VU meter on my software here, so that I can tell if we have any audio problems. So I'm excited about today's show. We have a lot of cool stuff. Thank you for tuning in early. We have a school event for my son today, so I had to get this in early and then go do that. So let's see. First off, let's start with our coupon code of the day. And my little thumbnail of it looks like it's the wrong one. Let's see if this pops up correct. Ah, it is correct. Okay, Circus. Today's coupon code is Circus. If you type that in during checkout from the Adafruit store, you'll get 10% off of your entire purchase, excluding gift certificates, subscriptions, and software. So check out the good stuff in the Adafruit store. See if there's any new products this week that you're interested in. By the way, for those of you who tune into this but don't know about some of our other shows, which I highly doubt, but maybe someone exists like that, there are loads of great shows on the Adafruit video channel, and those go out on YouTube, on Twitch, on Facebook, on Periscope. Where else? That's the main places, right? And on Wednesday nights, we have Show and Tell, where community members come and show their stuff. And we also have Ask an Engineer, where Lady Ada and Mr. Lady Ada show off all kinds of great stuff, talk about news and history, and bring on guests. We had Mike Dole, the industrial designer for Adafruit, who's done a bunch of our cool cases, as well as those light-up cufflinks. He was on last night. And there is a new products segment in that show towards the end. So if you go and check out the show, look towards the end, you'll see all the new products that have come out this week. So anyway, back to coupon code Circus. That'll get you 10% off. And speaking of new products, let's talk about the product of the week. My pick for this week for product of the week is not this coffee, excuse me, but the TT motors that we have in the store. So the TT motors that we have, there are actually 3 of them now. So TT Motor is a name, I think the original company out of China that made this particular size of gear motor for running little cars and robots was called TT. Now I think that name may be sort of genericized. But here's a TT motor. This is a typical plastic geared one that gives a reduction of 1 to 48, I think. It's a pretty fast motor, but has a little bit of torque to it. And these are neat because they have little shafts for the motor's transmission running out both sides, which sometimes is very useful. But the one I'm excited about today is this blue one that I just got, and there are actually 2 of these. There's the all-metal one, which I think is somewhere around here, and then this is the bi-metal one. So this one has some plastic gears and some metal gears in it, which means that it runs a little quieter than the all-metal one. The thing about both these blue ones is their gear ratio is 1 to 90, so you get a lot more torque. You get about half the speed of these guys here. And we're going to use one of those in the project today. Now, a couple other things about this. One, be careful when screwing on screws to things, because I managed with something, with a different screwdriver, a very thin screwdriver yesterday, I managed to puncture my thumb, so I'm bandaged up today. And it was because me being stupid, I was holding stuff with 2 hands and poking at it and trying to drive a thing too hard. You need to clamp stuff off in these cases, but I survived it. The TT motors, have a little M3 or 3mm threaded shaft, as well as a flatted on both shafts size here. So my kind of co-product of the week is this pulley. And this pulley, you can see it has a little groove in there where you can put a string or belt that you're running. It has some attachment points on here. It is flatted to couple properly with these TT motor shafts, so it'll fit on there, and it's a tight fit. Whoops, this is how I end up poking myself. So once you get that in there, it turns with the shaft, but it also has a screw hole to keep it on there because it can kind of wiggle side to side. What I did was I just drilled this out a little bit so that I could put an M3 screw in, and you can see here, put that through. And we're going to use this one, I think. Let me put this one together fully and properly, because we're going to use this one in today's project as I kind of rebuild a thing I started working on yesterday. There we go. We're on there pretty good. So once this gets screwed down on there, it's pretty nicely, securely on. And you can put on different wheels. We have, I think, 3 different sizes of wheels with rubber tires that you can also put onto these. And then there's also a couple of holes for mounting, which is you can mount with some screws. We have a little mount bracket that you can use, a nice little metal mount bracket, or you can use zip ties or kind of anything that you can fit through there. So there is our little TT motor. I've got a, I've got rechargeable batteries in here. So this is running at top about 5.2 volts. Rechargeables run at a lower voltage than alkaline. So you can use 4 rechargeables, whereas you'd probably want to use 3 alkaline if you're running a 5-volt motor. This thing probably runs anywhere from, I don't know, a couple volts would probably get it moving up till 5 or 6. So you can see we get a nice torquey. You can see there it takes a good bit of force to get it to actually stop. You also draw a lot of current when you stop motors like that, so we'll be careful when we're plugging it into our Cricket later. We'll be running this with a Cricket and a Circuit Playground Express. So that's the product of the week. And let's see. Yeah, zip ties are the new duct tapeness. Zip ties are pretty great. Let's take a look in the chat here. Let's see. Be careful. Rectangular drive shafts remind me of 365 PF miniature air-gapped tuning caps and small AM radios. Oh, interesting. Those things are cool. Those big, weird air-gap capacitor fan things. Someone is... Mr. Certainly must be following me on social media, where I posted the message from my mom earlier today. I'm sorry, Mom. Asking me if I had gotten my rabies shot after stabbing myself with a screwdriver. She meant tetanus, and in her defense, English is not her first language. She's Italian, so we'll give her some slack. But it was fun to make fun of her, poor mom. All right, and good. All right, so we're good there. So now let's move on. So project today is going to involve this motor. It's also going to involve our coupon code Circus, which I mentioned. Remember this guy? But I'm not going to go all the way and talk about the project yet. First, we've got a couple other things I want to take care of. The next one being Make Code Minute. So I'm trying to keep these a little briefer. This is not a project today that's built in Make Code, so I won't, by necessity, have as much that I need to cover. So I just want to kind of cover one little interesting tip in Make Code. So let's switch to our magical see-through green-screened Make Code here. And I'll try to keep my head out of the way, or keep the things off of my face. So what I want to show today in Make Code is a brief little introduction to the JavaScript side of Make Code. So this is kind of a entry level into scripting rather than doing visual block-based stuff. And clearly one of the great strengths of Make Code is the visual style of dragging and dropping, and the logic that kind of makes the flow chart as you're building the program, or vice versa. And I love that. So one thing, however, is that when you're doing repetitive things, it's sometimes easier to go and deal with text. So here's a really nice example of a case when I would use this for real. So what I have here are 2 blocks that are on button down and on button up. And if you look over here at the simulator, let me point the wrong way, that's hard to do, but if you look at this simulator here, when I press the A button down, it lights up red. And now when I release that mouse button, it lights up blue. Red on down, blue on up. And so that's why I have these 2 blocks here. Button A, down, set all pixels to red. Button A, up, set all pixels to blue. So if I want to now set up, say, 2 different colors on the B button here. Right now the B button doesn't do anything. I could proceed to duplicate these blocks and change their individual drop-downs and colors. I could build it from scratch again, so I could say drag in a on button A, let me put it under my face here, switch that to button B, switch that to down, and then go get the lights block. It's not terrible by any means, but in some cases you're doing things enough that you want to copy and paste your text. So if you look up here at the top of Make Code, you'll see that we have not only the blocks interface, which is the one that we see by default, but we also have JavaScript. So now if I switch to JavaScript, it's going to go right in my face, and it might be hard for you to read. So if I drop this down a little bit, you can see it, but what I decided to do is actually copy and paste this text, which is the text that occurs, oh, that's kind of readable. Maybe we'll leave it like that. That's the text that is generated automatically, or the code in JavaScript that's automatically created with those blocks. So what I can do is copy these, and I'm going to paste them. So now if I highlight that, just so you can see it a little better, let me make sure you can still see that. Yes, you can. The new set here, input button A, I'm going to switch to B. Down, I can leave it down, and I'll probably change the color. It might be easier to change the color out in the block because I don't know the hex colors off the top of my head. So let's look at this. If I just switch button A to B there, so that's what I just switched, input button B. And same with this second one here, button B. Now if I go back over to the blocks, it will generate those for me. And now it sort of messes with the layout a little bit, so it's back on my face. Sorry. So we'll move these over here. So there's the button B. We'll leave the button A's over here. Okay, so now I can change the colors. So let's say we get yellow and we get purple. You'll see over in the JavaScript now, if I highlight these, we have different colors listed in their hex values, but that was easier for me to do over here. Oh, look, it kept the layout that time. I guess it's because I didn't add anything. There are little files being saved sort of in the preferences of your session, I think, that store these things. So now, if we go over and look at our simulator, I can press the B button and go from yellow to purple, or the A button and go from red to blue. And this, of course, would now be downloaded to my actual Circuit Playground Express by downloading this UF2 file. The Circuit Playground Express, when I double-click the button, shows up as, the reset button that is, shows up as a USB drive. I drag the file on, and we're done. So that is a brief introduction to the powerful side of the JavaScript half of Make Code, which I encourage you to take a look at if you've been getting experience with Make Code and you want to try doing some more advanced things or some bigger things where it can get a little cumbersome to duplicate blocks all over the place. And it's not a one-way street. So long as you use code that is understood by the block side of things, you can go back and forth between the graphical and the text interface. So that was your Make Code Minute, sponsored by my coffee. All right, so, well, not coffee panic. So, let's see. Oh, Control A may, yes, David, Control A would definitely be a good way to quickly pick all that code. I think you're absolutely right. So let me move this out of the way now. Nice to cross things off. How are we doing? Okay, it's 11:17. Everything seems to be up and running. How's Facebook? Did that start? It did. Good. Hi, Facebook. Hi, Vance Lewis. We don't usually chat with Facebook because there's just too many possible chats to look at all at once, and I get distracted easily. Congratulations, John Shaftstyle in YouTube chat says he has paid his property taxes. Ugh. All right, so the next thing I want to do is jump into a cardboard tools, tips, techniques thing, and I also have a couple of little bonus tools, tips, techniques things. And I know that I'm cutting into my time to do the real project, but I can't help myself because there's so much cool stuff to talk about. First thing I want to talk about is, you know this Lego tape, this sort of rubbery, flexible Lego tape with adhesive on the back? The Ruiz brothers have a guide on printing your own if you have some Ninja Flex or other flexible stuff. This is some commercial version of it that I got for Christmas as a Christmas present. I assume it's from that Kickstarter one that started the whole craze. And I hadn't used it much. I'd stuck a little piece of it to my monitor and then stuck some Lego blocks on it, which was cool. But recently, for no particularly good reason. I stuck a bunch onto the back of my iPhone. I have a iPhone SE, the kind of 5-sized one, and I didn't have a case on it, but I put on this rubberized Lego tape, and it's super fun because now I can put a crank on here that doesn't do anything, and it's kind of like a fun thing to fidget with and put blocks on and off. It's pretty easy to pop them off. And this makes a pretty good little rubbery surface to set things down on. And you can also, I don't have many blocks around here actually, you can set, here's some, what are these good for? All right, these are weird shape. But if you set blocks on them at certain heights, you can make like little stands for them while you're watching videos or charging or whatever. So I am excited about doing more with that. I have one piece of advice that I learned the hard way, which is don't put down the tape first and then think that you'll have lined it up well enough. Just get a big like Lego plate and put all the tape on that first, peel off the backing and set that on here, and then they'll be even. I have some that are not quite perfectly lined up. They're rubber, so they'll give a little bit, but it would be better to do it the smart way. So anyway, Lego backing, super excited about that. I'm thinking of covering it in Lego heads. That'd be kind of fun and weird. Next tool tip, let's go over to the workbench, and I want to talk a little bit about cardboard tubes and cylinders and other round shapes in cardboard. So, dun dun dun, we are in Tools and Techniques, and let's head over to the main workshop camera, and let me hide that Tools and Techniques thing before I get over there. Oh, and you know what? I'm going to plug in my camera switcher because I forgot to earlier, and hopefully it'll work when I get over there. So let's go to that view. Okay. We good? I think we're good. I'm bringing my coffee with me. And I just clicked a bunch of stuff in the interface, but it looks like audio is still working, so hooray. And I got to turn on the chat machine over here. Whoops, I just blew it away. Come back. All right, and I just got to find our, there we are. Our YouTube. Let's pop up the chat as live chat. We're good. All right, so here we are. Let's move some of this cool AdaBot stuff out of the way for a moment. And I'm going to zoom in a little bit with this overhead camera. So much paper and cardboard. Let's pull this cutting board over here for a second. Okay, so let's, well, I want to talk about cardboard tubes first. So cardboard tubes, you get them from your wrapping paper, like gift wrap tubes. That's where I got this one here. This is the one I was testing some of these principles of the finger joints before I made the hand last week. So it's a paper board, just like a chipboard, very thin, spiraled usually. So at least the way this type is made is, I didn't get a good, zoom in a little closer here. In fact, let's switch that to be the main cam. So you can see here, if I get that fully peeled off there, so it's wound around itself and glued down with a little bit of an overlap. Let me pull this string out of here and cut off a slice. So this is also toilet paper tubes, paper towel tubes, and then you get some nice, you can get thick, heavyweight tubes that sometimes a poster might come in, all the way up to sonotube if you've ever used that for pouring concrete. They're big, huge, thick-walled tubes that are amazing. People build telescopes out of them, all sorts of projects where you need a really nice, thick, not too expensive tube. Fake columns for theater sets often made with them, and they're much cheaper than columns that were kind of sold for that purpose. So here are a little basic tube. If you want to use this in a project, there are, depending on what you want to do, some interesting techniques. So one, let me get a little scrap of cardboard here, which my shop is covered in these days. All right, this was part of that hinge from last week. So if I want to mount this, there are a few options. One is to mark and cut a hole and drive that tube through if you need it to be on both sides. You can also either flange it just to stick to the surface, or you can run it all the way through and flange it on the other side. So let me show you what I mean by that. If you want to flange it, and I'm going to go a little quickly here so this won't be as accurate as it should be, but I'm going to try to, let's see, is any part of this straight? No, it's all crooked. All right, so I'm going to attempt to draw a straight line around there like that. And then I'll just take either scissors or a knife, and I'm going to snip little cuts spaced about a ½ inch apart, which we can then bend out and use as a flange to connect to something else. So just like this, we can go onto a surface. I have one somewhere around here. Where'd it go? I had a nice little example of that on a postal. Oh, here it is, right on my workbench. So you can see then you could glue this down, pop rivets through it, zip tie rivets. I just put some blue tape on there for now to test it. But you can see it's not super sturdy, and that's partly largely because of the taping instead of using glue. But it's good enough depending on, it's good enough for some purposes. If it's a decorative element, it wouldn't take a lot of force this way to knock it off. You can see it's peeling off. But same principle, right? So we've got a taped on flange. Or you can go here and cut this little circle out. Let me grab a knife and cut a little circle out of here. And then we'll be able to push the tube through from the other side and leave the flange on that side. We could also use multiple layers for it to go through, and then the sort of extra support of these walls will help it. Sorry I didn't pre-cut that whole cooking show style for you. All right, so we pop that through. How about we'll go through like this. Let's see, I need to take a little more off. And again, this is such a great way to prototype things that maybe you're planning to go and cut from wood or 3D print something or laser cut layers, but nothing like cardboard for very quick prototypes. Nothing, I say. Okay, so if we pull that through, now when we tape or glue this down, it's just to prevent this from coming out, but you can see the stability of this is higher just because of this little 4 millimeters or so of corrugated edge that are bracing this. And we could glue, in fact, I got my hot glue gun. Why don't we put this one on here nicely? So all I'm going to do is run this out a little bit and put a bead, kind of a thick blob of it underneath here. And it's okay to get that up into the edge where it touches. And now put a dot under each flange piece there. I don't know what a flange piece is called officially. And now we'll run this up here, and I'm just gonna, let me use something like the back of this pencil so I don't get hot glue all over my fingers. Okay, we'll push those down. You could then now back this with something else if you needed to have a floor to this. If you want it to continue to go through, you could put a ring to support it, but the hot glue itself is going to hold this on pretty nicely, I think. And there we go. We've got a little bit of glue that came up and around here that's now hopefully up on the walls. And that'll serve pretty well. That'll be pretty strong on there. It's really the limiting factor a little bit at this point is the strength of this lower piece. And we could go on and laminate more board, especially if you put crisscross grain. So grain is running this way. So if I take a piece like this and run it the opposite way, say put it under here, this becomes really rigid. by comparison. You can see here, this wants to bend on this axis, this wants to go on this one, put them together, and much, much stronger. You can put 45-degree angles if you want to get crazy with it. So that is mounting your tube as a flange. And let's see, I think I'll end it there. I have some other tube-based stuff, but I think that's a good tip for today. And I want to save a half hour here for our project build. So let's move over here for a second and let's discuss this project. All right, here I am, I'm back. Well, I'm gonna check out the chat because we got some good tips here, I think. Plastic food wrap has a nice thick permanent core. Oh, that's a great one. Yeah, inside of like aluminum foil or shrink wrap or a cling wrap. Very nice. What else? All sorts of good stuff in the chat. Yeah, Nis, I wish that were a magneto crank on my phone. That would be cool. What else? Copy paper rolled on a good form. Yeah, I was watching a YouTube channel of a guy who's a master craftsman with papercraft and cardboard, and he built a sort of a motorcycle handlebar for playing a Android phone game that used acceleration or accelerometer for tilt, and I think he built some little capacitive throttle or brake and clutch. So he made axles from rolled paper. I think he had like a thin piece of wood and just rolled a ton of paper. What YouTube channel is that crafter? That's a great question. I'm going to have to look that up after the show and put it in the chat. So look for that on Discord, unless someone wants to find it. How would you find it? Yeah, he made a motorcycle game controller out of cardboard. That's one to look for. And everything else is made like working Nerf guns and stuff like that, all kinds of crazy things. Great tips there for using a lot of different cardboard tubes from different products. So check out your cling rack, steal stuff out of your aluminum foil drawer, good stuff. Okay, so for the main project today, I wanted to take this idea of having our gear motor and pulley and balance the pulley, as you can see it wants to tilt back, by putting Circuit Playground Express and Cricut and battery pack in the right spot so that we could hang from a string and move back and forth. Oh, I got a window there I want to hide. What's that one? Get out of the way. Okay, if you look behind me here, you'll see a string. I'm going to switch over to this camera for a second. Can I go into the corner? I can. So this string here, oh, I can't point at it. I've got running between two pipes that I've clamped to my workshop's rafters on one and one of my workbenches on the other. So it's a loop of string. And part of the idea for this came from our own, oh yeah, someone found it in the chat. So it's Monster Kook, M-O-N-S-T-E-R-K-O-O-K is the guy who built the incredible cardboard steering wheel for a motorcycle game. So our own C. Grover in our chat has done a series of string racers that are little DC motors and battery packs, and it's evolved over the years to use microcontrollers like a trinket to sense the end of the rope with limit switches or accelerometer to deal with swinging. So he has a tutorial in the Adafruit Learn Guides on building string racers. So check that out. So I wanted to make, at first actually my idea was to do like a gondola or a cable car type of thing. And so the evolution of this, let me just pull this out, is that as I was putting together some cardboard to hold the Circuit Playground Express. So if we start here, actually let me go to full screen again of this. If we start here, so there's my Cricut and Circuit Playground Express. And then I wanted to carry the battery pack here so that this pulley was in a fairly well-balanced spot. So you can see I've got my motor and I've got my pulley attached to just a backing piece of cardboard that I wrapped around and made a little octagonal board to screw the Cricut into using some nylon 3mm or 2.5mm standoffs. And then I got a battery pack in there. So I can plug my battery in here. And I added a strip of neopixels because I have an idea that evolved from this gag, which is I built a little pivoting leg. Since I needed something to support the motor on this side, I had this side free, so I used, again, a little nylon standoff and looped a piece of cardboard that you can see I've put some supports in. So I got this little 90-degree bend here that's pretty strong. And hanging off of it is this little sort of robot body and leg. And oh yeah, thank you, Nis, for pointing this out. I needed a way to be able to take the battery pack in and out. So I used a brass paper fastener here as the attachment. So if we open this up, this is what holds the battery pack in. And I wasn't sure if I'd need to adjust things. I definitely need to be able to take the batteries out, so I couldn't just glue that in place, and I didn't want to just have it kind of in there by some miracle of cardboard holding it on. So let me take this out of camera view and put the fastener back in. I just cut a little slit in it. Okay, so yeah, brass fastener makes a pretty good little reclosable lock thing there. So by taking a couple pieces of cardboard here, oh, why am I in two views? Sorry. A couple pieces of cardboard here with pivots, I have this leg that can move. And since I have clearance on the front of this face, I decided to put the tip of the toe into the pulley here. And you can see when that motor turns, it's going to give us the illusion of a little leg moving, moving our wheel like a unicyclist. So actually, I've got the metal gear in here, and I would like to later switch it. I think we won't have enough time. At some point, I'll switch it to this bimetal gear. I'm not putting enough torque on this that I need to worry about stripping gears, I'm pretty sure. So I would get a quieter performance out of that bimetal one, since some of the gears are plastic and metal on metal is really loud in these things. But we'll go with the loud one for now. So I've got all this put together. Let me show you what the code is looking like currently. Let's see. Give me a second. I'm going to open over here in Atom. And do I have that in Mu, the current one? Let's see. No. I'm going to plug in this board. So again, this is one of my favorite things about Circuit Playground, is that since the files live on the board in their intact format, they're not compiled, I can plug in my Circuit Playground Express here, because I was programming it on a different computer, but I can essentially transfer the file using the Circuit Playground Express like a USB drive. I can just open the file up off of there. Let's see, do I have a Mu? Maybe we'll look at it in here. Ha, I tried to steal my audio, but I caught it. All right, so let's zoom that in a bunch. And let's try to, okay, I'm actually going to close this one. And now I'm opening it up off of the board. So there it is. Okay, so this is my, let me zoom that again for you. So this is my sketch. So what I'm doing is I'm, like you'll see with these Cricut, when we're programming Cricut stuff, move that out of the way a little bit, and I'll step over here. When we're programming Cricut stuff, you'll see some patterns emerging here. So we're going to import the I2C so that we can talk to the Cricut. The Cricut board is what's actually referred to as the Seesaw. It's the same as our Seesaw products as a coprocessor chip and I/O expander. We're bringing in the motor, the PWM. Actually, I don't need the PWM, do I? Yeah, I do. And then the board itself, I'm importing neopixel because I'm using that. I'm importing time so I can pause. And I'm importing audio I/O so that I can play wave files over the speaker. Then I define some names of colors that I want to use on the neopixels, because I wanted to be able to talk about those efficiently in a program, like run through some colors by saying the 0, the 1, the 2, the 3 of this array of colors. I'm instantiating neopixels in two different names. One is pixels, and those are the onboard neopixels that live on the Circuit Playground Express, as well as balls, which is this strip of 20 of them. And the reason I called them that is I'm going to have my character look sort of like it's juggling these balls. Then we create the seesaw object. We create one motor object. I have some variables here. I'm going to up this one. This is going to be the amount of time that the motor runs in one direction before it switches. So let me save that to the board. This is huge down here, but I think it's saved to the board. Let's see, what else am I doing? So I made a little proc, or a little loop here to run through and set the colors on the balls. And it's this long strip, and I just want to light up the last 5 of them. I set up this little music player that'll play this circus.wave music file. I have a little definition of this thing called juggling, and juggling is just running through different colors on kind of a little slow motion, almost like a neon sign juggling thing, where it's going to run through these 5 colors on the 5 balls. So that's the first thing we'll do, actually, is juggle. Why did I say 6 times? I guess I'm doing it 4 times. Juggle n number of times. Then it'll run through its loop 4 times. Then we're going to set the pixels on the neopixel, some of them to green, and that's to point in the direction that our unicyclist is going to move. And then we turn those off. We throttle the motor on for whatever the speed I set, which up here I set that to be half speed, I think, 0.5. And we run for the runtime. So in this case, we'll run for 6 seconds at that speed. Then we will turn all the neopixels on the board red to mean we're stopping. We will stop by setting the throttle to 0, and then we'll juggle 4 times, reverse, and repeat. So that's what's on the board. Let's do it right here where you can see it, and then we'll go and load it onto the Tightrope that I built. Look at it over there. Oh, I can just hide that. Where'd that go? It's gone. All right. That's one way to do it. Can you hear me? Yes, still. Okay, so this speaker's really loud, so let's see if this works. Oh, he's juggling, but you can't see those neopixels. Sorry. Now he's riding. Now he's going to juggle. Did he juggle? Did I have him juggling there? I'm not sure what happened. Did I pull this out? I did. Oops. All right, I'm holding the ground to there, so it should. Yeah, you can't see them too well, but those little neopixels are going. Yeah, so let me pause this thing. So I'm going to turn this off real quick. So you, if you're new to Cricut, it's got terminal blocks for connecting to a bunch of the types of things you'd want to connect to. So I've got here a set of 3 blocks. This screwdriver is too big. Now I'm scared of that little screwdriver that punctured me. Let me find that thing. Where'd you go? There you are. So we've got 3 blocks for the neopixel. And that's a 5-volt signal for data line telling the pixels what to do, and then ground. My ground came out. One of the cool things, by the way, is that we're using, this is a 3-volt logic board, the Circuit Playground Express, but there is a logic shifter, a level shifter for the logic levels that neopixels expect, which is 5 volts. So this is a proper thing. Okay, so that should work now. Let's bring it over to this cool place and see it in action. This is a little downshooter that I have just pointed out, so it does. I don't know if it's gonna, how well it's gonna focus. It looks, oh, it's trying to focus. Let's hit the focus button. Like I say, these things usually have an algorithm that wants to focus on faces. I don't know about this one in particular, but should be. All right, so neopixels we'll ignore for now. So what I'm going to do is I'm going to load this into here, and I've got the pulley sitting on this front string. It's a loop, as you can see. And then that little overhang nylon spacer I have on top of the other one. That's kind of a safety in case this slips for some reason. I have a second attachment point. So let's turn this on. I'm just going to hold the neopixels for now. So he's doing his juggle pattern. And there he goes, motoring along. I don't have any smarts in this right now as far as logic for when it stops. I just tuned it for the right number of seconds to not run into the ends. I think I had this running at 1, the speed of 1, and that would go end to end. Now I've got it running at a half speed, so it doesn't go as far. And it works pretty well on this level. I think I tried at one point when I was thinking more gondola going up at an angle, and it would need some grippier string or grippier maybe a rubber band inside of the pulley channel so that it didn't slide. Okay, so that's the basic idea, and now what I wanted to do, if we have time, is try to make this look a little nicer. So let's switch to that camera there, and how about that camera there? I can zoom out a bit here. So the Ruiz brothers have been working with their Cry-Cut machine, which is a little CNC drag knife cutter that you see used for craft stuff. Scrapbooking is the world it originally came from. And they've been doing awesome stuff, and the thing is, when you're creating things to be cut in a Cry-Cut, you're usually generating vector files that you then cut in sequential layers. So I don't have a Cry-Cut, but I have a laser cutter, so I asked them last night, hey, can I have the vector files you made? They said, sure thing. So I was able to cut out the dark blue for some of the backing elements of the robot, of Adabot, and then a light blue. It's not quite on-brand light blue, but it's what I had available. This is just cardstock. And so I was able to then sandwich those together and make, this is part of the leg, this is the other part of the leg. So I separated these files out using Rhino and made these, this is the original, what it would look like. So I made the chest sideways, got rid of the lightning bolt, and right now I just have the arms on with magnets, but this is just a nice sandwiching of the different, oh, sorry, let me give you this as the big camera. Get back here. There we go. So there, this is, what, 4 layers here. So I've got the dark blue, the light blue, I've got the white in there to give the teeth and the eye scleras, and then I've got these little pupil iris black ones. And so I put these, for now, just on with a couple magnets. I'm not sure if I'm going to want to move these. The magnet ought to at least hold it on for now in place. So I want this guy to look, or Adabot to look like, is Adabot a he or a she? Adabot, she? He? Oh man, who knows? Why do I not know this? Is anyone from Adafruit in the chat? What gender? Maybe Adabot's genderless. Why does it matter? Our good friend here, Adabot, is going to maybe be juggling. But to ride the unicycle, what I need to do is pin the leg at the hip and the knee and the toe with a little, some sort of a pivot. And one idea I wanted to try actually was to just attach those to the existing mechanism I have here. So since this is acting sort of as a skeleton that already does the motion I want, I might be able to just glue or otherwise attach at the center and hide the pivot there. Sort of like just dressing the robot like that. And it's not a perfect fit because this was accidentally this close to this, but I didn't measure anything. This was just by eye. When I made the cardboard part, I didn't know I was going to do the robot part. So let's try that, and then I think this maybe go under there like that, and maybe we'll just do the one leg. So we might as well try some hot glue for this. I say, why not? And I'll just put a couple little dots so that we can recover from our errors if we don't like how it works. And this is actually something I know when I was working at Disney, we talked a lot to people who had been around during the early days of Pirates of the Caribbean and maintenance that then goes on for decades afterwards. And one of the big challenges with the audio animatronics in the parks is the wear and tear, particularly clothing that moves a lot and is dressed on top of an armature kind of like this. At certain points, it just gets torn apart. So it's a challenge between the creative and the maintenance side of things, how to best set up those robots, which is what they are essentially, so that they look good, but they also aren't constantly breaking down. All right, and we can fit that in there. I think my little magnet is going to get in the way, so the body is going to ride a little high, a little higher than I thought it should, but we'll go with that. I guess I could put the magnet all the way through the cardboard, but for now, let's try it like that. I could put the arms up a little higher too. My best friend, the hot glue gun. Joe Bowers, if you're watching this, yes, I've come around and I love hot glue. Someone asked about, oh, and someone answered it. Thanks, Todd. Yeah, the edges definitely don't look as nice when you laser cut them compared to the cry cut, which is, I don't know if you can see it on the camera here, but there's a little bit of a charred edge to them, which you don't get if you use a blade. Solomon Farsi says, I want that Atari joystick pin. Oh yeah, this is from my friend Coop, Chris Cooper. Look up Art of Coop online. Some of his stuff is a bit adult, so be warned, but he made this beautiful illustration of an Atari joystick, and I got a pin from him of it. Glue gun is so hot right now, it is. Orange tennis ball at the lower end of the galvanized pipe. That's a hazard. This thing, yeah, that's a good point. That's going to kill me. Do I have anything I can put on there real quick? Let's put, it's a mad search for what I can use to make that pipe safer. It's got to be something. A light bulb, that won't do it. I could wrap some of that Lego tape around it. That'd be kind of fun. I don't think it'll stick too well, honestly. What is this thing? Oh, that's a Gemma in a little case. That's no good. All right, for now, we're going to put some blue tape. When I've been walking around the shop trying to not decapitate myself on this, I've been hanging clothespins on it so that I can see them. That might catch my peripheral vision a little better. Yeah? What about this one? This one's high up. I'm not going to hurt myself on that. Famous last words. Okay, so this should be cooled off enough now to give it a try. Let's try it right here in the real world, or in the workbench world, before we stick it to the Tightrope. All right, can you see that? I think you can see that. Can puppeteer it to pretend we're on there. Start juggling. You can't see that at all. Don't fall apart, Adabot. Hey, looks pretty good. Woohoo! All right, I'm satisfied with that. Now, in the interest of time, before we rather than testing that, which is what we should do, I want to see if we can come up with a nice way to mount these neopixels so they look like the juggling balls that I envisioned. So what I'm going to do is run them up the back. Let me switch cameras again. Let's go to that one. And what I should do is trim this strand so that it's just the 5 that I need. But I'm not going to do that, again, in the interest of time. So we'll have a bunch of disused neopixels up the back here, and maybe I'll just tape those on. Let me get some beige masking tape. See, look at that. Just cut my head off again. I don't like this masking tape for this use because it's pretty sticky and it leaves residue compared to the blue, but the blue will be noticeable back there. So just wrap that like so. Okay. And maybe we could illuminate the back of the world with it, I don't know. Oh, I got a lot of excess. So what I want to do is take these 5, 1, 2, 3, 4, 5, and have them kind of just up in the air near Adabot, like so. So it looks like some juggling is going on. It's not very stiff wire, and I couldn't find any armature wire. I know it's in here somewhere, but I didn't find it. So we will just use tape, I think, for now. So again, I'll take a little bit of this, and maybe I'll embed a paper clip in it so that I can attach it to the cardboard and adjust. So let's turn this into kind of a circle, like so. Oh, I'm hiding that, I'm sorry. Oh, good, a weed whacker is going off out there. Okay, something like that. All right, and now let's see if I can paper clip that to the back of this. There's nowhere good to do that. All right, tape it is. All right, it's going to be a bit farther behind than I wanted it to because I don't have a good surface and I don't think the Adabot will support it. One thing you could do is put the Adabot, if you cut that out, you could also cut it out of cardboard and layer it with the cardstock so that it's a stiffer bot. All right, so this will be a bit of a suggestion of the juggling, like this. So let's switch to the other camera. And I might as well, yeah, I'll let the speaker dangle. That needs to be mounted too. All right. Oh, I may have obstructed my path to this back connection here. Okay, so we won't use that. That's, whoa, 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 we're falling over. Oh, it's gotten heavy, hasn't it? And I'm only on a single point there. All right, let me strap that down. And where'd your foot go? In that one? To connect the foot, there are, like I said, these little attachments on the pulley. So I'm running a 2.5 millimeter nylon standoff or nylon screw into one of those attachment points. And I bored it out a little bit so that it's a loose fit that doesn't impede the motion. All right, get that strand of hot glue off of you there, Adabot. Shall we give it a try? I think we shall. Oh, my juggling balls, did they come out again? There we go. Oh, well, I see one lit. Oh, I have them pointing the wrong way. Come back, Adabot. There you go. Let's switch this out. All right. Juggling balls need some work. The other idea I had was using some enamel wire and individual neopixels so they would you could barely see what's holding them, which might be cool. All right, let's try that again. I'll start you over here a little further. Oh, your foot came out. It would be a challenge with this one to do both legs, I think. They would kind of need to both be on this side of my pulley because the axle would get in the way from the motor if it were on the other side. But if I put the other leg in the opposite side of the wheel, you would get like a straight leg when that one's bent and the reverse. So it's definitely possible to do a cool 2 legs on the wheel type of thing. All right, let's see. I'm not seeing the neopixels at all, so I really do think I have, my ground wire fell out too. All right, let's try to fix that. There is, by the way, if you've gotten a Cricut early, there is a firmware update that came out yesterday that I haven't even had a chance to try, but I think it fixes this issue where sometimes this neopixel on the seesaw, on the Cricut board itself, turns white for no particularly good reason. So that fix should be out there if you're an early user and want to try flashing that, you can. So that serial port, or USB port rather, at the bottom of the Cricut is just for updating the seesaw with new firmware, the Cricut board itself. Oh, yeah, the magnet on that speaker just grabbed me. All right, let's see if I can get this in here. Oh, I twisted that pretty good when I was mounting it, and it pulled the ground out. Sometimes I like to solder the wire, tin the wire a little bit before using it in these screw clamp or screw terminals if it's thin wire. It helps it just to thicken the wire up a little bit so you can get a better grip. Is everyone in there pretty good? I think they are. Okay, so let's fix you. Like so. And yeah, my cardboard armature that holds up the puppet is thin. It wasn't meant to hold up these neopixels, so now they're wanting to bend. So put a little tape there to prevent that. Okay, do your thing, Adabot. I want to see some neopixels. Yay, neopixels, which you probably can't see on camera. But they're there. It's juggling. All right, that'll look cool at night. Oh, your foot fell out. Yeah, this bend is bad. All right, let's fix that. I'm gonna take it off of here. Or should I leave it on? I'll leave it on there, but so what I'm gonna do is add a little piece of cardboard to strengthen that structure. So get a little scrap. Sure, this was a demo door. So as long as I keep the fluting going counter to the bend that I'm getting here, it doesn't take much cardboard to repair that kind of a bend. Since I've already got tape on there, I don't think I'll use hot glue, but I should reinforce this thing later. And most of these problems are due to my ill-conceived NeoPixel strand plan back there. All right, so you come back here. Yeah, I've also got a bit of friction. The tape is actually touching this guideline. And let's put the foot in. Okay, I think it'll work now, though. I'm feeling confident about you, Adabot. Here we go. There's juggling of neopixels. Yeah, there you go. You can see how much heavier I've made it with those neopixels too. It's really pulling that line down. Ah, whoa, I caught it. Yeah, that safety didn't help. All right, let's pull the neopixels off. I'm more interested in seeing it properly tightrope walk at this point. Let's turn it off and not try to just get it on there while it's moving. All right, I think I gilded the lily with the neopixels a little bit there. Oops. Why are you tipping so much now? What did I change? All right, I'm going to unscrew the neopixels here. There's a really cool unicycling animatronic made by Garner Holt, Garner Holt is one of the few companies that makes stuff for Disney for the parks that's outside of Imagineering itself. And Garner Holt always wanted to be an Imagineer, but I think he never worked at Disney, and he just did it on his own. As a kid, he started doing animatronics, and he has a really cool unicycling bot that's worth checking out on YouTube. All right, Ada, let's see you do your thing. That would be the juggling right there. That's not happening because I got mad at the neopixels. Oh, that leg is going to go backwards. You're not a bird. Whew. What did I ruin? Oh, this is very loose, that's why. There we go. So right now, because there's not a lot of grip there, if it hits the end, it just kind of keeps going. So one idea now that the tension is there, it's working a lot better. One idea that Lady Ada had is pretty cool. Since we have the light sensor here on the Circuit Playground Express, we could add a little light blocker when it gets to the end, maybe just a little cardboard flap kind of thing, so that when the Circuit Playground Express goes behind that, that level of change in the lighting could indicate that we've reached the end. And you could maybe even do that in advance, so that maybe a second before it gets to the end it slows down, decelerates a little. Right now I'm not doing any acceleration or deceleration in the motor, but it's definitely something you can do in software. So the possibilities of putting in either limit switches or light sensing to let us know that we're nearing the end are pretty cool. And this, I'm not doing anything super advanced here. This is not like a balancing robot. But you could, if you look at the one that Garner Holt made, you could definitely do some fun stuff by moving back and forth and then forward and back and forth to make it look a little more lifelike, like it's someone on a unicycle who's trying to balance. But just on its own, because it has this sort of single point that it's resting on the line, it does some nice back and forth, especially you'll see when it stops, that feels a bit like someone trying to balance. So way to go, Adabot. You're pretty good at this unicycle thing. All right, I'll leave that running, and we're just about out of time here. We're a couple minutes over, but thank you so much for coming by to the workshop today. I appreciate everyone in the comments. Oh, look, someone posted, yes, thank you, Mr. Certainly, posted the Garner Holt animatronic. And the evolution of this has been fun. It was just a case of I really was going to do a gondola type of thing, and then something about watching that pulley go around because it has those mounting points. I thought, ooh, this could be kind of a cool little fake leg mechanism. And I'm sure I had that unicycling animatronic in my head. So I just want to remind you before we go that we have a 10% off code today in the store, which is Circus. And if you use that code in the Adafruit store, you'll be able to get 10% off of anything you buy except gift certificates, software, and subscriptions. Today's project is, I'm going to do a learn guide on it, but today's project is the Cricket for Circuit Playground Express. Circuit Playground Express, a TT motor. That's the noisy bimetal or fully metal one, which is way stronger than it needs to be for this project, and I think our little friend here, the Whisper Quiet bimetal might be a good choice for this project. So I think I'll swap it over for that and see how it goes. And a battery pack. We have a 3 AA battery pack. That's this cool kind of waterproof one that has mounting flanges on it and everything. That's all that's on there, and a little speaker. And maybe neopixels, maybe not. But you can see on that one, let me switch back over for a second. I've got, let me turn off the coupon code. Can you hear me? Yeah, if you look on there, oh, it's a bit bright to see that. My neopixels are switching to green in the direction that they're going. They're green right now. Then they stop and go red, and then they'll switch the green direction. So we are using the onboard neopixels just for kind of a fun little effect. So that is the Tightrope Unicycle bot. I'm John Park. This is John Park's workshop for Adafruit. Thank you so much, and I will see you next week back at the regular time. Bye-bye, everyone.
Wow.